green ecosystems, also to current work in the architecture document. So if you want to participate in that, you have to join Gaia-X and participate. And then you can also vote. So you can downvote or upvote your favorite ecosystem requirements. Thank you for that. We have heard in the beginning by Eleni Dede from the Information Society that Gaia-X and the concepts of Gaia-X is not like a single project and they stop. And in the same vein, I think I welcome the Petteri from X-Road and the Nordic Institute of Interoperability Institute. You will correct me, because that certainly is more than a single project. And I think you are going to tell us the current technological state, what has happened in the past, and hopefully also what you plan for the future. The floor is yours. I think your slides should be the next.
Yeah, thank you very much. And good morning or good afternoon, everyone. So I'm going to tell you a little bit about X-Road. First,
can you place the next one then? Exactly. Yeah,
yeah.
Perfect. Yeah.
Yeah. So I'm going to tell you a little bit of our product X-Road. First, I will tell you more about generally what X-Road is, what it does, so that it's kind of easier to then share more details about what we are doing with data spaces and why. But let's start with a very short introduction to the Nordic Institute for Interoperability Solutions, NIIS for short, the organization that I represent. So NIIS is a non-profit association which mission is to develop digital government solutions to its members. Currently we have 8 members and we are open also for new members. NIIS was originally established back in 2017 by Estonia and Finland, and since then over the year we have expanded our activities and also increased our member base. We started our data space journey back in 2020 by looking into data spaces, and then over the years we've got more involved. We have joined Gaia-X as a member, the IDSA, the Eclipse Data Space Working Group. So we have, instead of just following, we have become contributors to various data space initiatives. And the main reason why we originally started to look into data spaces was our main product X-Road, which is an open source product for secure data exchange between organizations. So X-Road is licensed under the MIT open source license, and it's one of the most deployed digital public infrastructure components out there. X-Road is also a digital public good verified by the Digital Public Goods Alliance. X-Road is not a new solution. Its first version was published already back in 2001, so it turns actually 25 years this year. However, originally it wasn't open source. It was published open source in 2015. And since then its use has, well, someone could say exploded really. So today we actually have 32 known X-Road ecosystems around the world. There was one more ecosystem announced since I made these slides, and there are almost 700 million people in the countries where X-Road is being used. So as you can see, X-Road is truly a global solution, and the ecosystem that is missing from the map is South Africa. And typically data spaces and data exchange ecosystems, they are deployed for a specific policy domain. For example, automotive industry, banking, healthcare, and so on. X-Road is a little bit different, since typically X-Road is deployed as a national data exchange solution, meaning that all different kind of organizations are using the same ecosystem to exchange data. For example, when looking at this diagram, you can see many different types of organizations. These organizations are taken from the Estonian existing X-Road ecosystem. So they are existing members using the same ecosystem to exchange data. And well, there is no reason why X-Road couldn't be used also for a policy domain or business domain specific use case. But I guess since this is the way how Estonia originally implemented it, it has become the most common way how to deploy it. But in the future, we are expecting to see more business domain specific implementations as well. Then how X-Road works in practice. When you see this diagram, well, you are all familiar with data spaces, and you probably think that, well, looks a lot like a data space. And it is true, that is the case. That's why I wanted to share this diagram with you. So even if X-Road today and in the past has not been a data space solution, but still the overall concept, how it works, is very similar to data spaces. So the main idea is that organizations, they exchange data directly with each other without any centralized components. In X-Road, the data space agent or connector, it's called the security server. Just like in data spaces, every organization has their connector or agent. In X-Road, they have their security server. Then in X-Road, the role of the data space registry is taken by the central server. So even if X-Road is a decentralized system to exchange data, it has some centralized components as well. And the central server is like the phone book, the registry of the ecosystem. It contains a list of all the member organizations, their connectors, and also the trusted trust service providers. So in X-Road, trust is based on X509 certificates, and the certificates must be issued by a CA that is approved by the X-Road operator. It can be an EIDAS compliant, generally trusted CA, or it can be a CA hosted by the operator. Doesn't matter as long as it's defined trusted in the registry, then it's okay in the ecosystem. Nevertheless, regardless of the central components, X-Road is very fault tolerant, and the central components can be out of order even for days, and it doesn't affect the data exchange within the ecosystem. Well, and then just like in data spaces, monitoring and data discovery plays a very important role, and X-Road already has existing mechanisms for both of them as well. Using, well, protocols and mechanisms that are publicly available but specific to X-Road. Then X-Road also supports federation, which in this context means connecting two X-Road ecosystems to one another. And once the ecosystems have been connected, then the members of the different ecosystems can exchange data with each other as if they were members of the same ecosystem. So they have their existing connector, and they can use it to exchange data within their own ecosystem and with all the federated ecosystems. However, the federation is always one-to-one connection between two ecosystems. It's not transitive, meaning that if we have ecosystems A, B, and C, and there is a federation connection between A and B and C, then A and C are not connected. But besides technical connection, also administrative side is equally important. So there needs to be a federation agreement between the two ecosystems, just like there needs to be a data exchange agreement between the data exchange parties. And according to our experience with X-Road, well, technically setting up the federation, it takes 15 minutes. You need to upload one configuration file per ecosystem, but then the administrative side, it's usually a little bit slower. Usually we're talking about months there. And there is no like centralized registry for federation, like meta registry. It's always defined and set up between the two ecosystems. And then X-Road can also be connected with other data exchange infrastructures. For example, Estonia and Finland are using their national X-Road ecosystems with the European one's only technical system that's based on e-delivery. So they have implemented a national gateway component that connects the two different infrastructures. But that's about how X-Road is today. And then next, let's talk a little bit about how X-Road is going to be in the future. So we are currently working on the next version of X-Road, which is X-Road 8 Spaceship. And like you have seen, X-Road today provides already interoperability within one X-Road ecosystem and between two different X-Road ecosystems. And it's even possible to make X-Road interoperable with other data exchange infrastructures. However, you always need to implement some additional components, some kind of a gateway and adapter, so it's not very scalable and sustainable if you need to be interoperable with many other data exchange infrastructures. And since data exchange is becoming more and more important all the time, and we can see that the organizations that are using X-Road, they are members of an X-Road ecosystem, but they also need to exchange data with other ecosystems and data spaces. And therefore, we want to make X-Road more interoperable, and the best way to do that is to transform X-Road into a data space solution. So in practice, we are going to replace X-Road's custom protocol stack to a data space protocol stack, meaning that when we used X-Road with X-Road, we always use the data space protocol stack. So we don't want to just add some kind of a plugin or some kind of a hack solution to make X-Road interoperable with data spaces, but really turn X-Road into a data space solution truly inside. And this is how the X-Road data space protocol stack will look like. So in general, we can say that there are 3 planes in the data space protocol stack: trust plane, control plane, and data plane. When it comes to trust plane, we are at least initially going to use the decentralized claims protocol. Then let's see, maybe in the future we might support OpenID for VC as well. That remains to be seen. And then on the control plane level, we will use the data space protocol. And on the data plane level, instead, we have the X-Road specific X-Road message transport protocol, which basically supports synchronous data exchange over HTTP using any message type content type, JSON, XML, binary, whatever. And the data plane, X-Road data plane, it provides a secure and unified way to exchange data. All the messages are digitally signed, timestamped, and logged. So that's kind of the extra value over a regular REST implementation. And the idea is that this is the initial stack in a sense, that in the future we expect to add support for additional data planes, because with this stack, X-Road remains interoperable with X-Road. In order to be interoperable with other data spaces, we must at least support other additional data planes. Then when it comes to the implementation of the DCP and DSP, we are not planning to write protocol implementations by ourselves, but we are using the EDC as a basis. So in practice, we are integrating the EDC into X-Road and use that as a basis of our implementation. So this diagram illustrates the X-Road protocols. So on the top, you can see how everything works today. We have the X-Road message transport protocol between the connectors, and then we have a different protocol, or two different protocols actually, that is used between the connected information systems and the connector. And what's very important, that in X-Road 8, after all these changes, the part that will remain the same is the protocols between the connector and the connected information systems. What will change is the protocols between the connectors. As you can see, we will add the DCP and DSP to that protocol stack. But then it's kind of transparent to the connected information systems, which means that these changes should be fully backwards compatible on a protocol level. So since we have at least 32 known X-Road ecosystems around the world, we cannot implement changes that would break backwards interoperability, and that's of course one of our biggest challenges as well. But yeah, this is how we are planning to do it. Then about technical interoperability with other data spaces and with Gaia-X. So one of our goals with X-Road 8 is to make X-Road interoperable with the Gaia-X trust framework. And on a high level, our approach is based on the Gaia-X participant credentials. So we are planning to make the X-Road agent interoperable with the Gaia-X digital clearinghouse. So basically, we might embed the Gaia-X credential wizard into the X-Road agent so that the X-Road participants may request for a Gaia-X participant credential. And then that participant credential can be used to authenticate the organizations when exchanging data with other data spaces that also support those credentials. And why we originally decided to take this approach is that X-Road and Gaia-X, they kind of already today have the same root of trust. Also in Gaia-X, when you request for a participant credential or any other credential, you need to have an X509 certificate issued by a trusted certificate authority. And in many X-Road ecosystems, the certificate authorities that they use, they are eIDAS compliant CAs, which are also trusted by Gaia-X, meaning that by default every X-Road member organization already has a certificate that they can use a root of trust also for applying a Gaia-X participant credential, and then that credential can be used with other data spaces, maybe also internally in X-Road. But in X-Road, we will also have our own X-Road participant credential that is the kind of the primary root of trust when it comes to X-Road. And yeah, when it comes to the X-Road credential, it has some similarities to the Gaia-X participant credential, but otherwise it's its own independent credential. It's not an extension of the Gaia-X participant credential. When it comes to the X-Road 8 timeline, we started the implementation in 2024. First, we did a technical proof of concept to see if our approach is technically feasible, and after that we kicked off the production implementation. The first beta version was released last year, and actually this year, just last week, indeed we released the second beta version, and the first production version is scheduled for December of this year, so in 6 months. And then, of course, we continue to release new versions regularly. And in general, we are doing the implementation using agile development methods, meaning that not everything new that we have planned will be included in the first release, but we will keep adding new stuff step by step in every new release. And then finally, I wanted to share some implementation challenges with you, since some of you might be working with a similar project and might be facing the same challenges. So first of all, I already mentioned the protocol level backwards compatibility. That's definitely a huge challenge, so that we can implement all the changes so that everything is backwards compatible and the migration is as easy and as automated as possible. Then the second one, supporting our current multi-tenancy model, it's maybe more related to the EDC than the data space protocols, but currently with X-Road, one organization may have multiple connectors, or one connector can be shared by multiple organizations. For example, we know that there are connectors that are shared even tens of different organizations, small organizations, and implementing support for the same model with the EDC has not been as straightforward as we were originally hoping. However, the relatively new virtual EDC, the EDC-V, has made it a little bit easier. So that's definitely a good improvement. Then managing DIDs and credential life cycles for participants that have multiple agents. That's a challenge in context of X-Roads, since the idea with DIDs and credentials in general is that one organization, it has one DID and one participant credential. But with X-Road, currently organizations with multiple connectors, they have multiple sign certificates. That is kind of the correspondent of participant credential now. So they have one sign certificate per connector. If they have 10 connectors, then they have 10 sign certificates. And in order to implement a model where we have one DID and one participant credential in X-Road, when they have 10 connectors, it will be challenging because, well, technically, of course, it's possible you need to have a wallet where you keep your credentials and a place where you host your DID documents. So basically, it's simple, but in practice, the way how these X-Road connectors are deployed today might make it very challenging for them to share resources like a wallet, because we know that organizations have multiple connectors that may have different kind of security classifications. Some may operate in very secure environments and others, well, less secure. And having some shared resource like a wallet might be challenging for them. So we cannot count on it that we require every X-Road user to support that kind of model. But we are currently looking into it and figuring out how to do it. Well, then the others, how do we handle existing access policies and ODRL? Well, it's a smaller technical question, rather how to map those things. And then when it comes to service descriptions, X-Road already supports service descriptions. We use OpenAPI and WSDL. And then with the data space protocol, there will also be DCAT. So one more way of describing services, additional metadata. So we just need to figure out how to link those all together, and then since there are existing catalog solutions already for X-Road, they of course should support DCAT, maybe not immediately, but at least in some time in the future. And then last but not least, and definitely not the most straightforward one, is aligning X-Road terminologies, APIs, component names with data space concepts and standards. So today we have X-Road Central Server, X-Road Security Server, and in the future, when X-Road will be a data space solution, we want it to be as easy as possible to discuss with other projects and initiatives, and therefore it's very important that we use the same terminology, that we don't need every time to explain that, hey, security server is actually an agent. So we need to do some renaming. And well, updating documentation is easy, updating UIs is easy, but then when we need to update protocols, APIs in a backwards compatible manner, then yeah, no, not so easy. So yeah, that's definitely a challenge. And then one funny fact regarding the terminology. So since X-Road is used as a national data exchange solution in many countries, and for example, Estonia and Finland, they have legislation that say that public sector organizations must use X-Road. And some of the component names, like the security server, the central server, they have been included in the national legislations. So the question is that if we change those component names, do the countries need to update their legislation as well? So good question, but yeah, maybe there is a lesson to be learned. So when drafting legislation, including technical details, it's rather stay on a more abstract level rather than include component names of a specific technology into the laws. Yeah, that's all I wanted to share with you. Thanks very much for listening. Thank you.